So today we're going to do something a little bit different from what we usually do on this channel. We're going to be doing a little Leetcode challenge where we solve 5 Leetcode problems in a row, nonstop. And these are all going to be string type problems, but even though they're all string type problems, they utilize a variety of different algorithms and data structures. So do not be discouraged by you won't be discouraged by the variety in these problems. So this is going to be completely raw and unedited footage. So if I looked at these problems briefly before I started this, and I have a rough idea of what to do, but I haven't implemented anything in details. So as I go along, I'm going to try to implement the solutions on the spot and try to explain my thought process and how I would approach these problems. So hopefully this will be a educational for you in terms of the coding interview questions that you may get. All right, so there are going to be 5 problems in total, and they are of varying difficulty. The first 2 are going to be easy, the next 2 medium, and the final one hard. So without further ado, let's get started with the first problem. And the first problem is called longest common prefix. So here's the problem description. It's very short. Write a function to find the longest common prefix string among an array of strings. If there is no common prefix, return an empty string. Okay, so here, as the first example, we have this array of strings, flowers, flow, flight, and the prefix FL is common to all 3 strings, and this is the longest one, right? So therefore, we return FL. All right, so the next one, dog, race car, car. There is no common prefix between all of these strings, so therefore, we just return the empty string. All right, so the problem description is very simple. So let's see how we can implement this. So the first thing that we can do is we can just think of like a kind of a brute force solution, right? So we just check, every possible prefix. So to construct the longest common prefix, we first got to check, whether the first letter matches in all of the strings, right? So in this case, they all begin with an F. So we know that at least it has to be F and then something afterwards. And then we go on and check the next letter, right? In this case, they all have an L, right? So then we can just add L to our answer. And then we just go on in this fashion, letter by letter. So for instance, for the next letter, here there's an O here, that's good. But here there's an I, right? So the third letter doesn't match across all of the strings. And therefore, that's where we stop and we just return what we currently have, FL. So that's the idea. So we just want to check, the letters in each of these strings one by one until we eventually get to a point where they don't all match, and that's where we stop. All right. So now we got to consider some possible edge cases. So if you look at the constraints, right? So first of all, the length of this array could be 0, which means that it's an empty array, right? So we got to take care of that. And also, any of the strings in the array could also be empty, right? It has length 0. All right, so I guess we can just first take care of the edge case where the strings array is empty. So if not strings, then we just return the empty string, right? Because in that case, there is no common prefix. Okay, so if the function hasn't returned by this point, we know that at least this array is not empty. So now we can just start checking, the letters at each position one by one from left to right. So I'm going to define this string called res. So this is going to be my final answer, and I'm going to build this answer up incrementally one by one, one character at a time. All right, so now I want to loop through the characters of every string one by one. So let's see. So I want to start by checking, if the first letters are all equal. So I want to get a first letter out of this. So let's see. So I want to loop through all the letters one. So I can do for I in range. Okay, and now here comes the tricky part. So where should I stop in terms of looping through the letters, right? So I should obviously stop on the shortest length string in this array, right? For example, in this case, the word flow has length of 4. So I don't want to loop, any further than that, right? Because otherwise, there are no more characters after this. So I want to first get the minimum length of all the strings. So I'm going to define, okay, I just calculate that, min, and then length of word or word in strings. And I want to loop from all the way to this m. Okay, so now I want to get the ith character. So to get the ith character, it doesn't matter what the order is. I can just pick the first word, right? So strength, and then 0, that's the first word, and then the ith character. And then at this point, I just want to check that all the other words have this particular character at the ith position. And if it does, then I'll add this character into my solution. Otherwise, if it doesn't, then I know that what I currently have is the longest common prefix, and I can just return. Okay, so if all, and I'm going to check some conditions here. So strings, so this is the jth word, ith character equals to this character for j in x range, for j in range length strings. So let me get rid of this like that. Okay, so if this is the case, then I can just add this character onto the res. Otherwise, I can just return what I currently have. All right, and that should work. Okay, so now let's consider the case where one of the words is an empty string, right? So in that case, then m will be 0, and this loop doesn't execute. So that means the function will never return. And in that case, I would just want to return the empty string. So I actually have to put another return statement here at the end for that. Okay, so now let's run this to see how this works. Okay, it gives me what I expect. Now let's try this. Okay, so I get the empty string. All right, so this should work. Let's submit it and see. And there we go. All right, so that's first problem. Now on to the second. Valid palindrome. All right, so once again, an easy problem, short description. Given a string, determine if it's a palindrome, considering only alphanumeric characters and ignoring cases. Okay, so for the purpose of this problem, we define an empty string as a valid palindrome. Okay, fair enough. All right, so here in this example, a man, a plant, a canal, Panama. Sure. So then if we only consider the letters and we ignore upper and lower case, then this is indeed a palindrome because it reads the same forward and backwards. Race a car. This is not a palindrome because here it goes RACE, and here backwards it goes RACA. So that's not a palindrome, so we return false. Okay, so the first thing we obviously have to do is we have to filter the characters by only alphanumeric characters because those are the only ones we care about. And then afterwards we have to also check we have to also, to figure out some way to convert all these upper characters into lower ones because we don't care about the cases. All right, so I'm going to define, I don't know what to call this. I'm just going to call it A. Very uncreative name, but whatever. So this string called A is going to contain all the characters of S that are only alphanumeric. And also, I'm going to convert all the characters into lowercase. Okay, so first we need to check, if a character is alphanumeric, right? As we loop through the characters in S. So we need a way of checking that. So we can define, we need to get all the alphanumeric characters first, right? So in Python, there is this thing called string.ascii underscore lowercase. And this is a string containing all the lowercase letters. There is a similar thing for the uppercase letters. String.ascii uppercase. And finally, alphanumeric, right? So numbers as well. So we need a string containing all the numbers. So I'm just gonna do that. Okay, so then we can just loop through the elements of S. So for char in S, if char in lower or char in upper or char in nums, right? So that means this character, if any of these is satisfied, that means the character is an alphanumeric character. In that case, we just add it to this, this A variable. All right, so at the end, at this point, once this loop is finished, A should consist of only the alphanumeric characters of S. But they may be a mix of upper and lower cases. So we need to convert everything to lowercase. So I think in Python there is a method, a string method called lower, that converts everything into lowercase, right? So in this case, we take care of the cases. And now finally, we just check if A is a palindrome. So we just check, return A is equal to backwards of itself. And this is how you reverse a string in Python. All right, so let's see if this works. False, okay. So let's see what has gone wrong. Just as a sanity check, I'm gonna print what A is at this point, so I can see, what it is. Man, this is taking forever. All right. Gonna refresh the page and try it again. Okay. Oh, okay. So here's what our A looks like for this example. And you can see that obviously the lower method didn't work because there are still some upper cases in there. What is the method for lowering characters? Oh, I think the issue is that this is actually returns the final string. So I actually have to do A equals. It doesn't do it in place, so it actually returns the string itself afterwards. So maybe this will work. Okay, there we go. All right, so I guess this is a lesson for this lower method. This lower method doesn't do the lowering in place, right? So you can't just call, a.lower like this. It actually returns the final string after the lowering operation. So you have to do A equals a dot lower, and now we get the right a, and we just check the palindrome afterwards. All right, just to make sure that this example also works, race a car, so this should return false. Okay, so this seems to work. Let's run it. All right, so there we go. Problem number 2 down. Third problem, group anagrams. Okay, so let's read the problem description. Given an array of strings, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original characters exactly once. Okay, so in this example, you have a bunch of words here, and we want to group the anagrams. So nat and tan are anagrams because they're both composed of tan, right? Just in a different order. And these three are anagrams because they're all composed of ate in various orders. And bat is a group all by itself. Okay. So the input sizes are pretty big. It could be over 10,000. There could be up to 10,000 words, and each word can be 100 characters long. So this algorithm definitely needs to be relatively efficient, probably have a runtime of O(n) or something like this. All right, so let's see. What's the defining character of an anagram, right? How do you tell if two words are an anagram? Well, two words are an anagram if they share exactly the same characters. So in particular, the ordering of the characters don't matter, right? So therefore, what we can do is we can just sort every single word. And in that case, if two words happen to contain the same characters, just in a different order, if we sort both of them, then they will end up being the same word, right? If they contain different characters, then they would not end up being the same word after we sort them. So therefore, to check if two words are an anagram, we only need to check if they're equal after sorting, after a sort. So therefore, to group the anagrams, we can just use the sorted word as kind of like a representative for each group, right? So for example, for this group containing these three words, if we sort each of these words, we will get AET, right? And AET, that string, can be a representative of this entire group. And we can know, if we get another word, we can check if it belongs to this group by checking if the sorted string of that word equals AET, right? Okay, so this clearly calls for a dictionary approach. So I'm going to define a dictionary called groups. And I'm going to default it to a list. So in this case, the keys will be the sorted words. So these are like the representatives. Representatives. Yes. Keys will be the sorted words. And then the each key will be mapped to a list. So key to list. And these lists will be the group of that key. All right, so we can just, so then we can just do this. So for word in strings, we want to append, we want to add this word to the group of this word. But the group of this word is defined by, the key to the group of this word is this word sorted, right? So we can do groups sorted word dot append, because this is a list and we want to add this word to that group. All right. And then finally, we just return a list containing the groups, right? So that will be groups key for key in groups, right? So this should work. Let's try this. unhashable type list. Okay. I think it's because the sorted returns a list and not a string, but I want it to be a string. Does this work? Does this return a string? Okay, so there is no sort method for a string. Okay. This is going to be a rather ugly approach, but I guess it works. So sorted word, this returns a list, but I want a string. So I can join this with the empty string. I think this should work. Oh, okay. What is the syntax of this? Oh, right. I think it's this, not the other way around. Okay. So this seems to work. So let me just explain what I'm doing here. So the problem here is that when I call sorted word, this actually returns a list. Okay. So for example, if I call sorted, like ATE, right? So this actually returns a list of A, E, T, like this. And of course, because the list data structure is mutable, you cannot use this as a key in a dictionary. So what I want to do is I want to convert this sorted list back into a string, right? And the way in Python, there is a string method called join. And this is what I'm using here. So what this is saying is that we want to join all the characters in this list called sorted word. And between each character, we want to, and whatever is in front of this dot is the thing that we want to add in between every item in this list. So in this case, I just want to join these guys, right? AET with nothing between them. So therefore, I just put the empty string up here. So this step, so after join, this will return AET like this. And this here now is a proper string, which is immutable, and I can use this as a key in this dictionary. All right, so it'll be interesting to check the edge case, right, or the empty string. So in this case, this should still work, right, because in this case, word will be an empty string, and this here would also be an empty string. So I would have an empty string as a key, and in that list, corresponding to that key, I will just have an empty string. So in the end, I should just get a list containing one empty string. So let's see. Okay, so that works. Just check the last example here. All right, so this seems to work. So let's submit this. Okay, so there we go. Third problem down. Now to the fourth problem. All right, minimum remove to make valid parentheses. So given a string S of open bracket and close bracket and lowercase English characters, your task is to remove the minimum number of parentheses in any positions so that the resulting parentheses string is valid and return any valid string. Formally, a parentheses string is valid if and only if it is the empty string, contains only lowercase characters, or it can be written as AB. So this is a concatenation where A, B are valid strings, or it can be written as open A closed where A is a valid string. All right, interesting. So here, in this example, we have Leetcode with some parentheses in the middle, And we notice that this close parentheses here does not have a partner, right? Because this, okay, so this open parentheses is closed by this guy. This open parentheses is closed by this one. But this closed parentheses does not have a corresponding open parenthesis. So therefore, we have to remove this, right? And that's the minimum we need to remove to make the string valid. So that's why the return, the output is this without, is just S without this last character. So it also says that this would also be accepted as correct. So alternatively, you can also remove this character as well. So that would also work, right? So that's also removing one character. And in that case, this guy will be closed by this, and this guy will be closed by the last one. So that also works. Okay, so in this one, this guy doesn't have a corresponding open parenthesis, so we remove it, and that's why the output is this. And in this case, we have to remove everything because otherwise, you know, there's no way to make this valid. Okay, so in this case, we just remove the first one because this one has no closed parentheses to account for it. So we remove this. All right. So basically, intuitively speaking, you know, these rules, when you read it, can be pretty complicated. But intuitively speaking, a valid string is where every open parentheses is closed. Okay? And of course, you have to close it in the right order. So the definition of, you know, the validity is pretty intuitive. So we can just make use of that intuition. And the first thing we notice is that the letters don't matter in the sense that they will not turn a otherwise valid string into an invalid one or vice versa, right? Because the validity of the string is essentially determined by whether or not every open parenthesis has been closed. So therefore, in terms of thinking about this problem, we can just, for now, ignore the letters themselves. That's a detail that we can figure out how to fill in later. But for now, let's just imagine that the string S is only composed of open and closed brackets. Okay, so in that case, how do we solve this problem, right? So imagine if we had something like this. Or maybe that's too simple. So how can you tell, you know, a string, for example, this one is valid? Well, first of all, at the very least, there has to be an equal number of open and closed brackets, right? That's at the very least. Because otherwise, you know, there will be an imbalance in the parentheses and, you know, either some open bracket is not going to have a closed one or vice versa. So there's no way it can be valid. So at the very least, the two types of parentheses have to be equal. But that's not enough because like down here in example 3, you could have, you know, equal number of parentheses, but that doesn't mean it's valid because they could be in the wrong order, right? So here, you know, there's 2 of each, but the closed parentheses, the open parentheses come after the closed ones. So this is no good. So how can we check this? So this calls for a stack type of data structure. But what we're after is not really checking if this is valid, right? What we want is what's the minimum number we need to remove to make it valid. So if we, okay, so here, let's try this. So we're going to have to read this string from left to right, right? So, and when we read from left to right, we're going to encounter some characters, right? So there are several scenarios we got to consider. So imagine we encounter this at this moment, okay? So if we encounter this, what do? Well, in this case, we got to check if there is this, an open bracket that hasn't been closed, right? And you know, if there is, then we can use this to close it. Otherwise, we gotta remove this character. right? Because if there is no open bracket up to this point that has been closed, then if we have a closed bracket, there's no way we can account for this. So therefore, we have to remove this, right? So there is no other option. We're kind of forced to remove it. Okay, so the other scenario is we encounter an open bracket like this. Okay, so in this case, what do we do? Well, if we encounter an open bracket, we may or may not be able to close this later on, right? So we don't know. So what we can do is we can keep it for now. And yeah, so we keep it for now because we don't know if we can close this at this moment. Okay, so in particular, what this means is that because we're dealing with stuff that we cannot decide on for the moment, we can't add characters to the final answer all the time. So that means we need to define some temporary variable to kind of hold the current uncertain characters that we're dealing with right now. Okay, so all right, so in order to check whether if there are open brackets that we have not closed yet, for example, this condition up here, I'm going to define a variable called open, open, and this is going to keep track of the number of open brackets that we have not yet been closed. And then this is going to be my final answer variable, and this is going to be my temporary variable. So this is going to hold on to all the characters that we're kind of uncertain whether it's going to be in the final answer or not. All right, so let's see. So let's loop through the characters of S. So for char in S, so first of all, if character is this close bracket, right? Then like we said before, we first got to check if there's an open bracket that we can use it to close. So let's see. So if open is greater than 0, right, that means there are open brackets that we can use it to close. So in that case, we closed one open bracket, so open -1. And we can add this character to our temp variable. Okay. And then the question is, when do we know if we can add all these temp characters onto our final answer? Well, if open is 0, right? If open is 0, that means we have managed to close every single open bracket up to this point, right? So if that were the case, then we know that the string of characters in this temp must be a valid string. So at that point, we can add this string onto the final answer. So if open equals 0, then we can add temp onto res. And then we got to reset temp to be empty. Okay. So let's see, if open is greater than 0, then we do that. But if otherwise, if open is equal to 0, then we have to remove this character, right? We can't include this close bracket character into our answer. So therefore, in that case, we just don't do anything. We just leave it as it is. Okay, so this seems good. And then otherwise, if we have like an open bracket, we don't know if we can, we'll be able to close this open bracket later, so we can just hold on to it for now. So open plus equals 1. So there's one more open bracket. And then temp plus equals this open bracket. Okay. So after, oh, and also, so if it's not an open bracket and it's not a closed bracket, then it must be a letter, right? So if it's a letter cannot change the validity of a string, right? So there's therefore no reason to remove that letter. So therefore we can just add that letter directly onto the temp. Let's see. So should I add it onto the temp or the result? I think I should add it onto temp. Okay. Yeah, I think temp is correct. All right. So by the end this finishes, so res is going to be some string. And I know that res is going to be definitely going to be valid because I only add stuff onto res when I know stuff is valid. And temp, this string may or may not be valid, right? So if it's not valid, then I got to check. Well, I got to remove some characters to make it valid. And then after I do that, I have to add the whatever remains of temp back onto res and return res. Okay, so how do I check if temp is valid? So at the very end, what are some possible scenarios? So at the very end, temp. So temp may have, so first, the question is, can temp have more this than this? And the answer to this is no, because I never add this, the close bracket, unless open is strictly positive, right? So I never add close brackets unless I know I can. So therefore, there's no way that I can have extra close brackets in the temp variable. All right, so that means there's only one other scenario. Temp has more this, more open than closed. Okay, so this is the only possible scenario. So in this case, I have to remove all the extra open brackets, right? And if you just think about it for a second, the order doesn't matter. The order of the removal doesn't matter. Wait, actually, no, it does matter. Yes, the order of the removal does matter. I have to remove. These open brackets have to be removed. Starting from the beginning. Let's see, is that right? So if I had something like this, So I have more open brackets than closed. And I have to remove them. Wait, this may be more complicated than I thought. Hold on. Okay, so no, they definitely cannot be removed from the beginning. Because if I had something like this, then I have one extra open bracket and I remove this one, then I get left with this. That makes no sense. So I cannot remove them from the beginning. I think what I have to do is I have to remove them starting from the end. Let's see. This feels right. I think I have to remove all these extra ones starting from the end. But I'm just trying to come up with a proof to convince myself that this is right. Yeah, I think this is right. Because for a valid string, all the closed brackets has to come after the open ones. So therefore, we have to remove the open ones starting from the end as to maximize. Yeah, so that means we need to prioritize open brackets occurring earlier on in the string to make this work, because closed ones have to come after them to be valid. So that's why, yeah, so that's why we need to remove them from the end and not from the beginning. Okay, so from the end. All right, so the number of open brackets more than the number of closed brackets is just this variable open, right? Because this by definition counts how many open brackets that have yet been closed. So therefore, if open is greater than 0, then we're gonna have to remove some stuff. Okay, so and we gotta remove this stuff from the end. So therefore, I'm going to, let's see, what's the best way to do this? So I basically have to remove this number of open brackets from the end of the string temp. And then add whatever is left onto res and then return res. So obviously there's a couple of very ugly ways to do this, but I'm just trying to think of like a prettier way to do this. Okay, fine. To make it easier, just gonna reverse temp. So now I have to remove this number of open brackets from the start, not from the end, after I reversed it. Okay, so for character and temp, if character is an open bracket, then I can do open -1. Right? So if open is less than or equal to 0, then that means I know that I have removed all the ones I need to. Okay, so this should be under here. So if open is less than or equal to 0, that means I've removed all the open brackets I need to. So I can just add that onto the res. Right? I don't need to remove this anymore. Otherwise, I remove it and I don't do anything. Okay, so if the character is not an open bracket, then I just add it onto the res. Okay, finally I return res. Okay, so this should work. Let's try it. For a character, wait, where is this? Line 16. Oh, not for, if. Okay, so this seems to work. Let's try this one. Ooh, okay. So I'm missing D here. Okay, so what has happened? So I'm missing D. D somehow didn't get included. All right, so let's check res and temp. What do they look like after this first loop? Okay, so res is this, temp is D. So this is what I would expect. So that's correct. So then that means D didn't get included in this final loop here. Ah, okay, I see. So the issue here is that by the time I finished up to this point, there are no extra open brackets, but that doesn't mean that I shouldn't go into this. So temp may contain just letters and not brackets. So in that case, I need to add all those letters back onto res as well. Okay, so oh no, wait a second. I don't think this part is correct. If I reverse temp, then okay. If I reverse temp, then I'm actually adding these characters onto res in the wrong order. Right? I need to add them in backwards. There must be a prettier way of doing this, but I can't think of it now, so I'm just going to use the ugly way. Define new variable temp2, and instead of adding on to res, because I have to add them on to backwards order, I'm gonna add them on to temp2 instead. This is super ugly, but it works. And then at the end, I reverse temp2 and add it on to res. And to address the issue of temp only containing letters, okay, so actually temp2 needs to be defined. Whoops. Temp2 needs to be defined outside of this loop, or else it will reset every loop. Okay. And to address the issue of, temp only containing letters and no brackets, I can make this greater than or equal to. And this will ensure that I go into this loop even if there are no open brackets. So in that case, this condition will never pop, right? This condition will never be satisfied. And at each iteration, I'll just be adding this character onto temp2, which is fine. Okay. Okay, so that seems to work now. Oof. All right. So what's wrong now? Right. So open bracket. Okay, so once again, let's check res and temp. So res should be empty. Temp, okay, that's good. Res is empty. Temp is these two open brackets. That's what I expect. All right, so that's correct. Then the issue is this final part again, which is, I don't like this final part. It's very finicky. And I don't like the way I've implemented this. There must be an easier way to do this, but I can't think of it. So I'm gonna have to debug this very finicky final part. Okay, so there are two opens in this case. Open should be 2 by this point. And I reverse temp. And then for character and temp, if character is open -1, that's fine. Okay, so if open is... So I only want to add this character if open is actually strictly less than 0. So because on the last open bracket I need to remove, this point I remove it, open -1. So at this point open is 0, but I don't want to add that character, right? Because I just removed it. So therefore, the condition I should check is not open less than or equal to 0, but only if open is strictly negative. At that point, I know that I have removed every single open bracket that I need to, and at that point, I can start adding on to the open brackets. Yes, I think that is correct. Okay. Okay, I'm pretty confident in this now. I think this should be correct. The logic at the end here is very, very ugly, or the code is very, very ugly. The logic is very simple. Basically, there could be some stuff left in this variable temp, and you just want to remove the last open number of brackets in this temp and add whatever's left onto the result and return that. It's very easy to explain, but when you write it out in code, I mean, it could be very ugly, as you can see here. Okay, so I think this should work. Let's submit it and see what happens. Okay, yeah, so not the best performance, only faster than 50%. But then again, I think it's because of my suboptimal logic down here, where, you know, first of all, there's a reversal, which is an O(n) process. And then, you know, I had to define a separate variable temp2, and at the end, there's another reversal of temp2. So this is like 2 extra O(n) steps that I think otherwise would not be there if I figured out a more clever way of doing this. But it works, and we'll go with it. All right, so last problem, which is a hard problem, palindrome partitioning 3. Okay, so very short description. You're given a string S containing lowercase letters and an integer k, and you need to first change some characters of S to other lowercase English letters, then divide S into k non-empty disjoint substrings such that each substring is a palindrome. Return the minimum number of characters that you need to change to divide the string. All right, so okay, so let's get some intuition as to what's going on. Okay, so S is ABC, K is 2. So we need to divide this into 2 disjoint, non-empty substrings, so that after changing some characters, each of them is a palindrome. All right, so the output here is 1. You can split the string into A, B, and C, and change one character in A, B to make it a palindrome. Okay. That makes sense. A, B, B, C, K is 3. You can split the string into A, B, B, and C, and all of them are palindromes already. So therefore, you don't need to change any character. So that's why it's 0. That makes sense. Okay, here Leetcode K equals 8, and this is 0. It's 0 because there are 8 characters in this string. So you can just have each character, you know, all by itself, and one character is already a palindrome. All right, so k is going to be less than or equal to s length. That makes sense. Otherwise, it would not be possible to divide it into k non-empty disjoint pieces. And the maximum size of s is 100 characters. Fair enough. So this small input size here tells me that I'm probably looking at like a n cubed algorithm or something like this. And this sounds like a dynamic programming problem. Okay, so let's see. So let's say we have like some string, right? A, B, C, D, E, F. Doesn't matter what it is. Let's say k is like, I don't know, 4. Okay. So what we can do is we can just try every single division, right? So we can just imagine a brute force technique. What would we do in brute force? We try every single division. So we first try dividing them like this, right? So this is going to be our first piece. So in this case, we check like what's the solution for if this were the case, right? So the solution for dividing the first piece here would be the solution sol, right? Or maybe solve, right? So the solution for A, B, C, D, E and k equals 3, right? Because for the remainder of this stuff, we only need to divide it into 3 pieces because we already separated out the 4th piece. And plus, how many characters we need to change in the 4th piece to make it a palindrome. In this case, f is already a palindrome, so it's 0, right? Okay, so if we divide it like this is the answer. But there are other ways to divide the 4th piece, so we can just try the next division, right? We divide EF instead. So this is going to be our 4th piece, and the answer to this will be solve A, B, C, D, k equals 3, plus, and then how many characters we need to change in EF to make it a palindrome? Well, that's 1. Okay, and the next one will be A, B, C, D, E, F. Okay, so you get the idea. So basically, we're just going to try every single possible division, starting from, let's say, you know, the end of the string. And the answer is going to be the minimum of all of this, right? So the answer for A, B, C, D, E, like solve A, B, C, D, E, F, the whole thing, k equals 4, is going to be the min of like all possible values of this stuff, right? So mim of this, and then the next one. So basically all possible ways that you can divide the fourth string out. Okay, so this is clearly a DP problem because the answer for this string k equals 4 depends on its subproblems, right? Okay. So we roughly know what to do, and now the question is how to implement this. So first of all, we need to we need to know these values here, right? So we need to know for any given ij, right? How many characters we need to change to make si to j plus 1 a palindrome. Because we're going to need these values when we do this DP, right? These are the values that we add on over here. Okay. So we're going to have to compute that. And then afterwards, I guess there's nothing more to do other than doing the DP. Okay, so I guess we can just compute this. So I'm going to define this dictionary called change. And this is going to keep track of number of make si to j plus 1 into palindrome. All right, so now how do we compute all these values? So for I equals x, for I equals range s, for j equals, for j in range starting from I all the way to s, this will give me every single ij pair. And now I need to compute how many characters I need to change. Okay, so there are several cases here, right? So imagine that si to j plus 1 is something like ABC, right? So it's an odd number. So in this case, the middle character would be, okay, so let's see. So this score is going to keep track of how many characters we have changed. And then I would have to loop. So to check if it's a palindrome, I would have to loop through from the beginning to the middle character and check, so for example, for the first index, I'm going to check if it matches the last one. And then for the second index, I have to check if it matches the second last one, and so on and so forth. So the question is just where is the middle, right? That's where I stop. So if, let's see, if j minus I is like an odd number, let's say it's 3, right? So that means I would have three characters, like in this scenario. So in this case, the middle would be j would be 0, 1. It would have index 1. So that means I have to stop so for t in range 0 to, where do I stop? I have to stop at j minus I over 2. Let's see, is that right? j minus I over 2 in this case, because of integer division, will be 1. So that's not good enough. I have to go to 2, not 1. So in this case, I have to add 1. All right, so, but if j minus I is even, if it's something like this, then I want to stop at 1. So in this case, 2 divided by 2 is 1, and plus 1 is 2. That's too much. That's 1 too much. So therefore, if ji minus I is even, then I don't want to add this 1. If ji minus I is odd, then I want to add this 1. So, okay, so I'm going to do a trick here. J minus I mod 2. So in this case, if j minus I is odd, then I add this. Wait. Okay, so what I'm just thinking about, what if j minus I is 0? J minus I is 0, this is 0, then this loop will never enter. So I think that's fine, because if j minus I is 0, that means we're looking at a single character anyways. All right, so I think that should be fine. Okay, so if s of I plus t is not equal to the character on the other side, right? So what's the index of the character that's on the other side? So that will be j minus t, right? So if this is the case, then I increment score by 1. Okay. Then by the time this finishes, I add this answer to change. ij equals score. All right, let's just check this is doing what we expect by printing change. Oh. Length of s. Okay, let's see. So it says 0, 1 is 1. That's correct. 1, 2, BC is 1. That's also correct. 0, 0 is 0, 1, 1, 0, 2, 2 is 0. That's all correct. 0, 2 is 1. That is also correct, because we can just change, like, say, A to C. Okay, so I think this part works. This change array, this change dictionary is doing what we expect. All right, so now we got to implement the DP. Okay, so DP, and this is going to take 2 arguments, so J and K. So this is going to give the answer for up to s of j plus 1 and the value k. All right. So now okay, so now we got to start looping through backwards. So what's the base case? So the base case is if k is equal to j plus 1, right? So in this case, there are the same number of characters as k, so therefore we know that we can just return 0 because, if you had like ABC and k is 3, then we just split each character by itself, right? We just split it like this, and in this case, everything is a palindrome, so the answer is 0. So that's the base case. Okay, so otherwise we continue. We gotta start splitting off the last piece, starting from the end. So this number t is going to count how many characters I have split off from the end. So it's going to be from 1 to something, and I'll figure out that something later. So let's see. So I should initialize the result here. Let's see, if I'm taking a minimum of a bunch of stuff, I should initialize this to infinity. For t equals x range 1 to something. So let's see, I should do res equals minimum of itself and the dp of, like we said before up here. So if we split off t characters from the end, that means that the ending character for the new dp is just going to be j minus t, right? And then k minus 1. All right, and then we have to add on how many characters we need to change for the last t characters to make it a palindrome. So this will be score or change of j minus t to j, I believe. Yes. So this is how many characters we need to change in the last t characters to make it a palindrome. And we add this on to this dp value, and that should be give our answer. And then finally return res. Okay, so now I need to figure out how far back I need to look for this value of t. I can't look too far back because at some point, this is going to be satisfied, right? I can't split off anything more. So, okay, so maybe it'll be helpful to do this. So if I had like this, for example, t is 1. Oh, okay, and let's say like k is 4, or let's say 3, right? So in this case, how far back can I look? I can look up to c, right? Because in this case, if I split it like this, then I will be calling k equals 2 on this, which is the base case, right? So therefore, I can split off 3 in this case, which is what? Which is... Okay, so the idea here is that I need to leave k minus 1 characters at the beginning. So that means... Okay, so to leave k minus 1 characters at the beginning. All right, so that means I need to... There are j plus 1 characters. And I want to leave k minus 1 characters at the beginning. That means this is the number of characters that I can split off at the end. right? J plus 1. And I want to include this value in my loop, so I have to plus 1. Okay. I think this should be right. Right, so let's try running this and see what happens. DP, obviously we want the length of S minus 1, and then K. Okay, let's see. Okay, so the recursion is not returning. So somehow I've overshot the base case. This is right. J plus 1 characters and A minus 1 characters at the beginning. So this minus that should be how many I have to split off. The maximum I can split off plus 1. That seems right. Not quite sure what's the issue here. Let's see. Okay, so they're just both going negative. Length S minus 1. So okay, so this has index 2. If this has index 2, then that means there are 3 characters. So therefore, I do if... Okay, so that means this will be 3. Okay. So down here, I split off 1 character. So J minus 1 is 1. A minus 1 is 1. I think there's one more case I have to check, which is, okay, so if k equals j minus plus 1, I definitely return 0. That's for sure. But if k equals 1, then I should return, then there's only one piece left. right? So in that case, I don't need to go any further. I think that's what's causing the recursion to never return. So if k is 1, then I should just return change of from 0 j, right? Because that's the only piece. Okay. So let's try another one. Right. It wasn't going to be that easy. Okay. So what's the problem here? Um, Four, three, one. Okay, so 3, 2, 1. So 3, 2 definitely should not give you 1. It should give 0. 0, 1, 2, 3. So that would be AABB split into 2. That should be, yeah, AABB split into 2 should give you 0. It shouldn't have any cost. So somehow I'm getting 1. Okay. Let's see. Let's go through this logic again. So if k is 1, this is definitely right. Okay, so just for sanity check, let's check this change dictionary. One, 2 is 1. 3, 3, 2, 2, 4, 4. 1, 4 is 1. 1, 4 is 1, that's right. 0, 2. 0, 2 is 1, that's also right. 1, 3 is 1, that's right. 2, 3 is 1. Sorry, no, 2, 3 is 0. Right, because that's BB. That's going to be 0. 0, 4. 0, 4 is 2. That's also correct. Okay, so it seems like wait. 0, 3 is oh yeah, 0, 3. Okay, so it seems like this change the change dictionary is all correct. So that's fine. That means the error has to be here somewhere in this DP. So okay, so if k is equal to j plus 1, then I return 0. I think that's definitely correct. If k is 1, then I return this. That's also correct. That means it must be here somewhere. Right, so t is the number of characters I split off at the end. So that goes from 1 to something. And there are j plus 1 characters. That's right. And then I need to leave k minus 1 characters at the beginning. So therefore, this is the number of characters I need to split off. And I add 1 because I want to include this value itself. Yeah, this seems right. What am I missing? K minus 1, j minus t. J minus t, j. Oh, wait a second. Okay, I think I know what's wrong. I think this should be plus 1. Because the way that this change dictionary is defined is that it's inclusive of the two end indices. So therefore, if I split off t elements from the end, the ending index is definitely j, but the starting index is j minus t. This actually takes me, j minus t by itself actually takes me 1 character before to where I want to start. So to get to where I want to start, I have to plus 1. I think this should be, I think that's the issue. Okay. Just to make sure that this first example still works. Okay. And in this case, okay, I don't think there's a point in checking this. This should just return immediately because this is the base case. Yeah, okay. All right, so this seems to work. But the problem is if we try to submit this now, we're going to get time limit exceeded because this DP is going to recompute many of the different results. So we're going to have to use some kind of memory. So I'm going to define this dictionary memo. And we're going to store in this dictionary results that we have already computed. And if we need those results again, we can just draw it directly from the dictionary and don't have to compute it again. So this saves time complexity. So, so if this pair, JK, is already in memo, that means we computed it before, so we can just return our pre-computed result, JK. Otherwise, at the end, once we have computed this result, we're going to add it to the memory. So memo JK equals res, and then we return res. Okay. So I think this should work now. Oh, not is in memo. It's not a good idea to type what you say. You gotta follow the syntax of the language. Okay, so let's submit this and see if this will pass the time complexity. Oh wow, it actually did pretty well. All right, so that's the end of this of these 5 problems. But now I just want to briefly explain how you can get a sense of what kind of algorithms that you need to use depending on the input size. Okay, so you may remember at the beginning of this problem, I said, you know, by looking at this input size of 100, I'm probably looking at like a O(n) cubed algorithm, right? So how do I know that? Well, typically when you do these problems more and more, especially on Leetcode, you can get a sense of like what. So typically you would have a couple of seconds for your code to run through all the test cases. And as you do more problems, you get a sense of what input sizes corresponds to how fast your code runs. Okay, so a good rule of thumb is that the n value, so your code typically can pass if it runs on the order of about 1 million, O of 1 million. Okay, so in this case, if n is 3, if n is 100, right? To get this 1 million, that's like n to the 3, right? So in this case, n to the 3 algorithm will probably work. So that's how I knew that, you know, I'm going to be looking at an n to the cube algorithm. And if you look at this algorithm, it is actually n to the cube. So why is that? Well, first look at this loop, right? So here I'm generating all ij pairs, right? So all ij pairs, there's about n squared of them, right? Roughly speaking. So that's n squared complexity here just for these 2 loops. And then for every ij pair, I then loop through all the values in between I and j, right? So that's another O(n) operation. So in total, populating this change dictionary is O(n) cubed complexity. So what about this DP? Well, the DP takes 2 arguments, j and k, right? So j can be, you know, anywhere between 0 and n. K can also be up to n, right? So in total, there are about n squared states, right? Roughly. Okay, so and for each state, when we do this computation, we're doing a minimum across a minimum across a maximum of n values, right? Because we're starting at the end of the string and we're splicing off 1 character at a time. And the most characters we can splice off is on the order of n, right? So for every one of these states, we have to do an O(n) operation to compute the minimum. So therefore, in total, this DP is also O of n cubed, right? And indeed, when we use memory, we don't have to recompute any of these states. So this is true n cubed DP. And it passed pretty well. Okay, so that is it for this session of Leetcode Challenge. There, you can, as you can see, you know, sometimes even when you have the right solution in mind, you try to implement it, your code doesn't work the way that you expect to, and there are tiny nuances that you have to fix. For example, you know, in this case, this little +1 here took me like, you know, what, I don't know how long it was, 20 minutes just to figure out. So it's stuff like this that that especially make these hard problems difficult. You have to be very, very clean with your logic in order to make these things work. But a lot of times, even in coding interviews, you will get a lot of credit just for figuring out the problem, even if the implementation is not perfect, because during a coding interview, sometimes they don't even ask you to run your code. They just tell you to write pseudocode instead and explain your logic. But yeah, so the implementation can be like a whole different challenge compared to figuring out the solution, right? This is almost like two separate skills. There are problems on Leetcode where once you figure out the solution, the code is like one line. Whereas there are other problems where like the solution is really simple to explain in words what you have to do, but the implementation is a massive pain. So they're both extremes, but is a good idea to get a feel for both of them. All right, so that's it for this section, and I'll see you guys next time. And I hope that this session has given you somewhat of some knowledge or confidence or education in terms of algorithms and data structures. But I hope you got something out of this. All right, that's it for now, and I'll see you guys next time.